have you look at Review Sheet 4, and Sam's got the right idea. Julian, we have separate paper out. They got a sheet of paper out. There's no way you can do it on here. So before I just asked you to pick and choose from this page, did anybody come today with a question, like you were actually studying and found something you didn't know how to do? Grace.
I had a question about like when you're like trying to find like the angle and then you do like two triangles, how do you know when to add or subtract like 180 or 2 pi?
Well, you just have to look at your picture. I mean, there's no like rule. You just have to look at your picture and see if it makes sense. So let me make up a problem like we're talking about. Suppose that we have something like 2 cosine x minus root 3 equals 0. Okay, and we're going to solve this equation. You want to do it in radians or degrees, Grace?
Radians.
So we're going to solve this equation from 0 to 2 pi. That's my clue, it's radians. If it were in degrees, it would say 0 to 360. So I'll add root 3 and divide by 2. So everybody okay with this? Now, that is a positive number, and it's a cosine. Where is cosine positive? Certainly quadrant 1. Where else is cosine positive?
4.
4. Now, that should not be a confusing thing for you. Cosine is x over r, x. Sine is y over r, y. If cosine is positive, then x is positive. And this is where x is positive, right?
Yeah.
Now, whatever it is, the adjacent over hypotenuse is root 3 over 2. Which means this is a 1. And this angle is 30 degrees, but I'm in radians, so pi over 6, since 30 is a sixth of 180. Now, this angle, I'm going to erase this root 3 here, this angle here is also pi over 6, okay? Now, what are the answers? Well, one of the angles is right here. Remember, this is 0. This is where we start. So one of the angles would actually be pi over 6. Right? The other answer is, well, I could say negative pi over 6, but not with those directions.
It's not on. It's 2
So
pi.
I gotta go all the way around to here.
Is it 2 pi minus pi?
So that's going to be, 2 pi is all the way around. But I stopped that far short, so it's 2 pi minus pi over 6, which would be 11 pi over 6. Okay, so Grace, you just gotta look at your picture, and your triangle will always either be sitting or hanging from the x-axis. So you're always gonna be doing something with 2 pi or 1 pi. This would, if you were up here, it would be pi minus that angle. If you were down here, it would be pi plus that angle.
So if it's in the third quadrant, then you plus it.
Wait, this would be pi, and don't you need to go more than that to get to the third quadrant? Yeah.
Okay.
All right, what was your question, Ryan?
No, I was
Yeah,
just
put your hand up.
no, I was just asking if it was whatever I said.
Okay,
Yeah, I don't
okay, I don't remember either. Okay, so anybody else come with a question? She came with a question. Who else came with one? Joe.
Oh, like one of the shaded region questions.
Okay.
There's one actually on the review sheet.
Okay, so which one do you want to do?
That's number 10. Whoever
Number
you're
10. Find the area of the shaded sector. So theta, the angle is 100 degrees, the radius is 6, and I'm finding the area of the shaded sector. Joe, what's the area of the whole circle?
2 pi r.
This is problematic. Area is pi r squared. Okay, Joe?
Yeah.
Okay, now listen, I was defending you earlier, you gotta make me proud. Area is pi r squared, okay?
What I said.
You said circumference, 2 pi r. So area is pi r squared.
I wouldn't got it right either.
See, Mrs.
Did you know that?
Yes.
So the area of the whole thing is 36 pi. So if I had shaded the whole circle, the answer would be 36 pi. But I didn't shade the whole circle, I shaded a fraction of it. What fraction is shaded?
2
100 over 360.
100 over 360.
Third
So
times 30.
this is the fraction of the circle that's shaded, Joe. Does that make sense to you?
Does make sense.
So I'm gonna go ahead and reduce that a little bit. So I have 10/36 times 36 pi. And these are gonna cancel. It looks like the answer is 10 pi. Now, there's no unit on that, so I don't need to put one on. But if, for example, if this had been 6 centimeters, then this would be square centimeters. If there's a unit given.
What's number 5 on the sheet?
Number 5 says, find the value of all 6 trig functions for an angle whose terminal side
Oh,
contains the
that's what that
point
means?
3, -1. So, or -3,1. So -3,1 would be over here, the point -3,1.
Is that what those like little like dash marks?
Yeah, just need to repeat the question. So, do I need to do this? Do you know how to find
No,
the
I
trig
know.
functions of that?
Yeah.
First,
I didn't know
find your
what the dash, I didn't know what
hypotenuse.
the dash was. I knew that.
All right, did anybody else come with a question already? All right, then take a look at this sheet and tell me what we're doing. What are we going to do on this sheet?
Ooh.
Let's go to 12.
I was gonna say that one.
Yeah,
Yeah,
I was gonna say
I was gonna say 12 too.
Yeah.
All right, so 12 says, we're gonna write, let's do one of them. It says write 2 equations. Looks like the second one might be a little bit harder, so let's do the second one.
That one looks tough.
Okay, so we're gonna write 2 equations for that second graph. And the second graph. All right, here we go. So when we say 2 equations, we mean a sine and a cosine. So. All right, so here we go. So we're gonna write a sine equation and a cosine equation. Now, when we do that, there are 4 potential numbers, right, that we can put into our equation. We have a number that we can put in out front, and then a number that's gonna be the coefficient on the x, something added or subtracted from the x, and then something added or subtracted at the end of the problem. I never graphed my picture, hang on.
Sine is
So, I have to decide, what equation I wanna write first, and it makes 0 difference, you're gonna write them both.
It's a negative sign.
So, okay, so
-4.
this starting here and ending here, Elijah says is a negative sign. Would you agree with that?
Yeah.
Now, there are other sign pictures up there, but we just gotta pick one and go with it, so I'm going with his idea, all right? So I'm gonna write the equation of the red thing. Now, it's a negative sign, and it has an amplitude of what? 2. It goes down 2 and up 2. Now, it's oscillating on that line, would you agree with me? Which means it has been lifted up. No, it's oscillating on that line, so it's actually been lifted up 4.
Why is that negative?
Huh?
Why is that negative two?
It's a negative sign. It goes down first. It's a negative sign.
Okay.
Hey.
Joe.
Now,
Here.
also, if that's what I'm looking at, I'm starting it clear over here.
Plus 2 pi
So
over 8.
this is gonna be x plus, and I would probably put pi over 4, but if you put 2 pi over 8, I wouldn't mark it wrong. That's how I have it labeled here. Right? But that's the same as pi over 4. And it's x plus, because remember it goes opposite, so that would move me backwards. Now, the red part that I have graphed
Stops at 2 pi.
goes from negative 2/8 to positive 2/8,
4.
which is a distance of
4.
4/8 or pi over 2. So the period of the picture is pi over 2. What's it supposed to be?
2 pi.
2 pi. Signs are 2 pi. Obviously, there's a number in here, call it whatever you want. There's a number there that has changed it.
4.
So 2 pi, the original period, divided by something is gonna give me pi over 2.
Yeah.
So somebody said that has to be 4. You could also cross multiply and get 4.
Yeah.
So that number right there is a 4. Now, we gotta do a cosine. The good news about the cosine is everything is going to stay the same except that. And this might be positive or negative, it depends what I look at. So with my green marker, I'm going to try to identify a cosine curve. Where do you want to start?
One on the left.
Start at 0, 4.
Here?
Yeah.
Okay, now that would not be a cosine curve, that would be
2
a
pi.
sine curve.
Uh,
Remember, if it's on the axis, it's where sine starts. It has to be the peak or the valley
so
for a
start at
cosine.
negative pi over 8.
So we can start right here. And if we did, we'd be looking at this right here, right?
The negative.
Now, that would also be a negative. Now, you could have started here, couldn't you? Couldn't you start here?
We start there
And then it would be a positive, okay? The only thing that's gonna change is where you started. If you started at negative pi over 8,
Plus.
then this is gonna be plus pi over 8. Ronan, if you started at pi over 8, it would be x minus pi over 8, and that would be positive then. And there are your 2 equations. Okay. All right, what else? On this page,
Wait, why is it a negative 2?
because we started at the bottom, cosines are supposed to start at the top. You have to remember what your basic shapes look like. Your basic shapes, your BFFs, you have to remember, this is what a cosine looks like. Starting down here, and it's negative. All right, who else sees something worthy of our conversation?
Number 2,
2?
the word problem.
Oh, the word problems?
Yeah.
All right, looks like Aubrey is walking at a pace of 3 miles an hour toward the Mass Hall of Fame building. This sounds like something we've already done. Let's take a look at it. Hello, how are you? I've missed you. All right, so here's our building. Aubrey is walking this way. At one point, the angle of elevation is 11, so we'll just make that 11. But she's walking this way, so after a while, her angle is 13.5. How tall is the building? Okay. Now, this is exactly like one we looked at last time. There's one more little piece of information in there that I know. What do I know? Joe,
She walked 3 miles per hour and she walked 15 minutes.
so how far did she walk?
Blades, 30.
30.
She's walking 3 miles an hour, and she walked for 1/4 of an hour.
Yeah, so 3.3.
0.75, 3/4 of a mile, that's right. Guys, distance is rate times time. Distance is rate times time. So 3 miles an hour, 1/4 of an hour, she went 0.75. All right, who remembers what we did yesterday? We gotta get another variable in there, so I'll pop one in right here. And I'll say tangent 13.5 equals x over y. And then I'll say tangent 11 equals x over y plus 0.75. And then I'm gonna solve this system. So I'll get x by itself and set them equal to each other. Since I just did it yesterday, I'm gonna do all that in one step. So I'm gonna say y tan 13.5 equals y plus 0.75 tan 11. Is that all right with everybody? Got x by this. Brought this over and brought this over, set them equal to each other. All right, now what? Now what? Distribute, yeah, so y tan 11 plus 0.75 tan 11. Then what?
Need to get a Y.
I gotta get the y's on the same side. And then I will take out a y, that's exactly right. And when I take out my y, it's gonna leave me with a parentheses, right? Tan 13.5 minus tan 11. And then I will divide by the parentheses. All right, let's take that in and see what we get. 0.75 tan 11 divided by parentheses tan 13.5 close parentheses minus tan 11. I got 3.19. Anybody else get that? Hey, you guys owe me some participation here, right? That's the deal we made.
Yeah.
I got 3.19, okay? Now be careful though, because what is that? 3.19 is the
You have to add that on.
y, right? That's the y. So remember that x is y times tan 13.5. So I'm gonna take this times tan 13.5, and x is 0.766 miles. Pretty tall building, I don't know how tall buildings are supposed to be. Anyway, that's what I.
That is pretty tall.
It's over 4,000 feet.
Because Denver's the mile high city and that's 3/4 of a mile.
Joe, how does that do?
Is the building's 0.76.
All right, my friends. Good question. Let's do another one. Who's got another one?
Thank you.
All this is fair game. The test won't have this many questions, but any of these questions is fair game.
15.
In which quadrant is an angle whose
Oh, wait.
sign is negative, so that means y is negative.
Yep.
And x cosine is positive. So where is y negative and x positive? 4.
4.
4, yeah. It's real easy. Cosine is x, sine is y.
Is that not one as well?
Which one?
Oh,
No.
17,
You said 19.
19.
19. It's Y.
Alright, let's do 17 and then we'll do 19. 17, I don't know which one you want to do. Let's just do A, I guess. It doesn't really make any difference. They're all pretty basic. So here we go. We're solving, no calculator. Sine x equals negative root 3 over 2. Okay? So this is like what I did for Grace earlier. Exact same kind of problem. First thing you gotta do is figure out where you are. So the sign is negative. 3 and 4.
Number 17.
Why is it quadrant?
Oh, 'cause
3
y
and
is negative.
4?
Oh, I was
Because y is negative in 3 and 4. So then, opposite over hypotenuse is root 3 over 2, which means this is a 1, and this angle is 60. I don't have any directions. I'm in degrees for this problem. This is 17, I'm in degrees. So I can make it 60. All of the angles, then both of the angles are 60. So now I need to start at 0 and come all the way around to here. So what will the measure of that angle be? The green angle? 240. Because you came to 180 and 60 past. So that one's 240. Then I gotta find the pink one, and it will be all the way around to there.
300.
That one will be 300.
Elijah wrong.
No.
You added wrong.
I know what you're hitting, bro.
It's okay, we all make mistakes,
Yeah,
okay?
I appreciate it.
Let's be nice to each other.
Sorry.
Is there a meeting before school on Tuesday?
No, we have office hours next week on Tuesday and Thursday. Tuesday and Thursday are the office hours next week.
We have tomorrow too.
And we have them tomorrow too. Yeah. Okay, number 19. Somebody said G19.
Yeah, number 19.
What is the period of the first function, the first half of the problem? What is the period?
5.
Pi. It's 2 pi divided by 2. So it's pi. So pi, 2 pi, 3 pi. What is the period of the second part?
2 over 5. Or 2 pi.
2 pi over 5.
So it's gonna be 2 pi. Or, no, pi. No, yeah.
It'd be 2 pi.
Looks like that's my first one, isn't it? The first match. So the period is 2 pi. Is it sinusoidal?
No.
No, because the
No.
periods don't match, they're 2 different periods. All right, what else? Come on.
Over 23.
Whoa,
Why not?
whoa,
We haven't
whoa,
done that.
25.
23. We haven't done that today.
25 and then 23?
Yep.
All right, so 25, how large is an angle determined by a 2/3 clockwise rotation? Well, how big is a whole rotation? 360. I don't want the whole rotation, I want 2/3 of it. So what's 2/3 of 360?
270 now.
Oh, never mind. I was gonna show you.
240. Now,
Oh,
watch it, because it says clockwise. You guys, stop it, Aiden.
You got
This
stars.
isn't period E.
He's distracting me with his, he's distracting me with his aura, his Eastern Kentucky-ness.
What up, 219?
What does clockwise mean? Clockwise means I'm measuring my angles this way, which means it's not 240, it is
Negative 240.
Negative 240.
So the clockwise tells me which way I'm going, and then the 2/3 of 360 tells me how far I'm going. Okay, what was the next one I said?
It was, 20, you got that period word.
23?
Yeah.
So I am gonna type, it says with calculator, I am going to type, oh, this is easy, you just type it in.
Oh.
I'll just plug it in. It's already like you didn't have to type it.
So tangent, doesn't matter, it actually makes no difference if in this problem which mode you're in. You'll get the same answer either way. So tangent, second sine, 7 divided by 8. 1.8074. Easy.
Number 20.
20. What is the period? Okay, that one is a little bit odd,
Oh.
but
Good question.
we can do it.
Is it too?
Hurricane question of
For you.
So what you need to do though is remember what happens when you take the absolute value of something.
It always is
So
fine.
here is my sine. Yes, we have taken the absolute value of things. If I take the absolute value of a sine curve, then everything, I called it bottoms up back in the day, everything comes up, right? So this is already up, but this one is also gonna come up. So if I took the absolute value of a sine, instead of going up and down, it's only going to go up, because it has to stay positive. Now, what is the period of that then? No,
No, it's not.
it's pi now. Now it's pi, because all I have is bumps. I don't have a hill and a valley, I just have hills. So the period would be pi.
So like, there's like mini circles, like, is there like?
They're mini parameters. Yeah. All right, who else? Yep. That's for the A students. We gotta have questions for the A students. That's one for the A students. Anna perked up at that. She says, all right, I got it. All right, who else? Patton, sit up, honey. Look like this is like,
You enjoyed it.
yeah, just pretend. All right, what else do we have?
Ooh.
Yes, Jerry.
What is another notation for,
You're not responsible for that. It's actually arc sign, but you don't need to know that.
Oh.
so just cross it off then?
Yeah, you can cross
Can we
it.
just do an arc length?
That's number 21, right?
We do a random arc like
Just like, I gotta remind myself now.
Or do something hard.
Just an arc length.
Find one on the sheet.
Yeah, I bet you want to.
Number 6.
Kobe, you got a question? You're sitting there very quiet.
6.
Get an A.
This 4. Did you get a Valentine?
Did I get a Valentine?
Yeah.
What?
Do you think I got a
She's a
Valentine?
husband like
It says
30.
unlimited.
Like, I don't know if
The
someone
last
posted.
Valentine I got was from Emil Ekior. You remember Emil?
Yeah.
Well, I
That's
mean,
big.
the candygram.
How big was it?
I did get from Sam, are you a bank loan? Because you have my interest.
Whoa.
I might use that. I might use that. I might use that.
Love can be taxing, but yours is like a refund.
This is 4. How big was it?
Bro,
All right, what else?
Let's go.
6.
6. Find the length of the arc, determined by an angle of 18 degrees, and radius is 6 inches.
Arc times arc.
Okay,
This is
so how do we find our
six.
Radius times radius.
radius?
Radius times radian.
So the problem is, my angle is in degrees. So over to the side, I will quickly, because it's a very quick thing, I will do pi over 180 equals something over 18. So x is gonna equal 18 pi over 180, which basically just reduces to pi over 10. Right?
Yeah.
So my arc length is simply going to be radius times radians. So 6 over 1 times pi over 10 is 6 pi over 10, or 3 pi over 5 inches. The arc length is inches because the radius was inches.
5.
All right? I just happened to look down. Number 4 has a tricky thing in it.
Oh, I saw that.
You want to be careful about number 4.
Whoa.
You see the trickiness? What's the trickiness?
The angle is
You're good.
You don't have a hypotenuse.
A what? A what?
Sorry, I know that word.
Look at the units. I have an airplane. I have an airplane. Number 4 in the word problems, I'm sorry.
I was looking at
I get why you're so goofy, yeah. It's number 4 in the word problem.
Okay.
The issue is, okay, first of all, we're finding the angle. The airplane is 2,000 feet above the ground, and the airport is 2 miles from the airplane. So this is feet.
You have the hypotenuse.
So I have the hypotenuse, but I gotta change it into feet. So 5,280 feet times 2.
12,000.
Do you see 10, 5, 6, 7?
Or 11.
So you see what, you gotta be careful, because some of you will just slap a 2 up there, and guess what? It's not going to be right. So make sure your units match. All right, let's go ahead and finish this. Sine x equals 2,000 over 10, 5, 60. How do I type that in? Do not waste time reducing that fraction.
Sine minus 1.
You're going to type inverse sine that number. Do not waste time. Your calculator doesn't care. It'll just take it just like that. So second sine.
10.91.
That's what I got.
Actually, you don't even have your calculator.
Actually, 10.92.
You didn't round. 10.92.
Robert, that was fast.
So 10.92 degrees. Let's do number 3 on the word problems. Number 3. A ship sails from port on a course of due north. Knots is nautical miles per hour, just a speed.
What number is this?
3.
You're good.
On the word wrong.
Alright, so here's my compass. Alright, so here's port, and the ship is going due north at a speed of 12 nautical miles per hour for 2 hours. So how far is that? Not up 12. 24. He's going 12 miles an hour for 2 hours. Then what does he do?
Then it goes west.
He turns due west, so that's a right angle
Oh, and
North.
that's hot,
to west
Oh, really?
at a speed of 13 knots for 1 hour. So that is 13,
Yep.
and now he's right there. What is his distance and direction from port? Now remember, that was port.
So you just do pi back.
So now we
I
need
thought
to
we
find
did
the
that.
distance, and how will we find the distance?
Oh, 24 squared plus 13
Pythagorean
squared.
theorem.
Pythagorean theorem.
I that's 25. I could be wrong on that, though, double check that. It's something, I know it's something.
Oh, I don't know. It's like weird.
Oh, maybe it's not.
Yeah, it's like 27 point.
Yeah, it's not 25. It's the square root of
Square root of 745.
It's all, yeah, 47.3.
27.2.
Oh my.
All right, so what is his distance from port? 27.29. Now, next question is, what is his direction? Now, the actual answer, remember, this is navigation. So his actual direction will be this angle right here. That is the angle that will be his direction.
I don't like that.
It will be bigger than 270, but less than 360, right? So could we find this angle right here?
Yeah.
All right, let's do that. The 24. Okay, so I'm gonna say tan x equals 13 over 24. Tan x equals 13 over 24. Does that make sense to you? What will I type into my calculator? Second tangent, 13 divided by 24. So that angle is 28.44. That is not the answer though. The
360
answer
minus.
is everything else, right?
Yeah.
So I'm going to subtract that from 360. And his course is 331.56 degrees.
We're done.
Let's look at part 11 real quick, part 11. These are little calculator problems. What do I have to be careful of with the little calculator problems in number 11? Are they radians or degrees? And how do you know? The degree problems will have a degree. So if there's no degree mark, then your calculator needs to be in radians. So let's just practice. Let's type in letter E, 11E. Now, it's a radian, so I gotta change my calculator into radians. And then I wish I could type in secant, but I can't. What do I type?
9 over 8 pi.
1 divided by cosine 8 pi divided by 9. You're exactly right, Sam. Negative 1.0642.
Yeah.
Cosine 8 pi.
Whoa.
All right, let's do one more. How about F?
1 over sine.
F is a degree, so change.
Yeah.
And then we'll type
1 over sine.
1 divided by sine.
We gotta use all those
18
buttons.
second angle degrees. 11 second angle minutes. And then 19 alpha plus. 3.2036.
Yes.
Cool.
Okay? Now, the opposite of that would be, look at number 7. These are no calculator. Find the exact value. Let's do F, the cosecant of 7 pi over 4. Now, this is no calculator. You will have a baby if you need help with arithmetic. But what are you going to do with cosecant 7 pi over 4?
First, let's get that
might get that in degrees.
Where are we?
So,
So cosecant 315.
Yeah.
So then we'll draw 315. Notice my labeling now.
Yeah.
I'm back to math labeling, normal labeling now. So 315 is all the way over here. Here's 315.
45.
That angle is 45. So 1, 1, root 2, negative.
Yep, and then cosecant, so hypotenuse over,
It's cosecant. It's cosecant.
hypotenuse over opposite.
Hypotenuse over opposite.
Root 2 over 1.
Root 2 over
Root 2
negative.
over negative 1. Yep, that's exactly right.
Okay.
Okay, let's do one more. D. This is 7D. We're finding the exact tangent of pi over 2. Last one. So that's the tangent of 90, right? And 90 is up here. So I
Need a
need my
circle.
circle.
That's right.
That point is 0, 1.
Yep.
So x is 0, y is 1, and r is 1.
What's
Tangent.
Y over X.
Y over x
Undefined.
undefined. Alright, so
Yeah, we're
next
done.
time I see you, we have a test. Anybody who I'm giving you my little Valentine.
Yay!
Completely optional. Completely optional.
Is that another review? More review?
Oh no, I mean it's math, but it's not review. It's math.
Is this for extra credit?
I don't believe I said it was extra credit.
Should it be extra
I said it's optional.
So it's extra credit.
Doesn't do extra.
Oh my God.
I will see you tomorrow. So
I don't know.
remember, if you want to stay after tomorrow and take the test when they do that.
Oh my God, I get my quarterback.
No, you don't.
Finally out of the shop, man.
Wait, what is your practice?
This had a lot of time.
Oh, it's fun.
I got my phone.
No. You grab it when you're doing
And I grabbed my phone.
We called it.